In the previous video, I introduced the physical meaning of the word dimensions. And we agreed that dimension is a physical quantity you can measure. And I give an example by distance. We usually have many parameters that you can now measure, especially we are living in a time that the sensors and the instrumentation for measurements is really going in an advanced way. But there is always fundamentals or basics quantities that we can measure, but we can use it to construct any other measurement that we are interested in. Let me explain more here. So we're talking about the fundamental dimensions. Let me actually fix that a little bit. Fundamental dimensions. The basic dimensions or the fundamental dimensions that we are dealing with is basically the distance and the symbol that we present distance in the dimension is L capital. The second quantity is time, and we give that usually T capital. Then the next one is going to be the mass, and we give that M capital. Then the next one is going to be the temperature. We give that theta. And there is the quantity of matter. I call that matter quantity. Which is given the M small. I mean by matter quantity here actually the moles, the number of moles, guys. This is the matter quantity here. Okay, someone would say, okay, distance has the, we usually express distance in meter. Yeah, remember, go back to the previous video. Meter is not the dimension. Meter is a unit. Meter is a description of the numeric value of the measurement. That's units. We will come to that later on. So let's focus now on the distance, time, mass, temperature, matter, and we'll look to the dimensions, how we express that physical quantity by symbolic here. So why did I call these fundamental dimensions? Because I can use these dimensions, the basics here, to construct anything else. You said that we have sensors, we have tools now to measure velocity, right? But what if you don't have a tool to measure the physical quantity of velocity? You're going to say that velocity is defined as distance over time. So if I can measure the distance, which everyone has a measuring tape, everyone has a stopwatch to measure the temperature, the time. So if you can measure these two, you can actually measure the velocity, right? So the dimension of the velocity is L over T, and we always prefer to write that in the form of LT minus 1. What about the acceleration? Acceleration is distance over time square, right? Which is velocity over time. It's the rate of change of velocity. So it's going to be distance over time square. So the dimension of the acceleration will be LT minus 2. What's next? Let's talk about force. If you have a device or a measuring tools or a sensor to measure force, that's great. What if you don't have it? Force is simply can be broken down into mass times acceleration. So if I can measure the mass, we can have a scale to measure the mass. What about the acceleration? We know that acceleration is velocity over time, and velocity can be broken down into distance over time. I can use measuring tape to measure the distance, stopwatch to measure the temperature, a scale to measure the mass. I can measure the force. Mass has a dimension of M capital. Acceleration is LT minus 2. So the force has a dimension, not unit. It's a dimension of LT, MLT minus 2. Let me fix that writing here. MLT minus 2. What will be next? Pressure. We're gonna explain these terms, guys, more details are in the upcoming videos, but I'm just showing you how simple you use these fundamental dimension to construct any other dimension. Pressure is usually force over area, and we did expose to that definition before under the name of stress, normal stress or shear stress, which is force over area. The force has a dimension of ml t minus 2, and the area has its distance times distance, so it's L square. If I finalize that, so the dimension of the force is m L minus 1 t minus 2, and so on. So this is actually conclude the definition of the basic or fundamental dimensions and how we can use these dimensions to construct other advanced measurements or quantity, physical quantity, to measure and get the dimension of these advanced term. Next, we're going to talk about the different types or systems of dimension that we are dealing with.